The idea behind it comes from some sort of science. Okay? So, scientific notation is one of those things that you're going to use a lot in science, especially when you're older. And it's one of those things that we talk about a lot in math, too. Okay? So, it's a different way to write numbers, some really large and really small numbers. In the past, you've talked about these things called atoms. Okay? What's an atom? Not like Adam as in my neighbor Adam, but an atom.
The smallest molecule.
Okay? It's a really, really small molecule. So when you talk about the size of an atom, you talk about like this weird length of this. Okay? Now the issue that comes apart with that is a lot of us can't really understand how small this really is. Same thing if I think about really large distances, from like here to the sun. Okay? You have some outrageous, really, really long number. Okay? Which a lot of us really don't understand how big it is. Okay? A lot of us don't even understand how big a million really is because we don't see things in millions. Like we don't have a million pencils laying on the ground. Okay? That's hard for us to visualize. So we use scientific notation. It's just a different way to write these types of numbers. And we're specifically going to talk about how to write really, really large numbers so that we can compare them and have a better understanding of what they mean. Okay? And we use it with scientific notation. So it has three things. The first thing is it has a number. The number's got to be between 1 and 10. Okay? It can only be one digit in front of my decimal point. No more. Okay? So that's why it's got to be less than 10, because 10 is 2 digits. Okay? Then it comes multiplication. It's always going to be written as multiplication, because we're taking really large numbers, and we got to get there using multiplication. And the last thing is called this power of 10. So my base is 10, and then I'm going to have some kind of exponent. Okay? This part of it here, this times 10, doesn't change. What we're going to deal with is changing this part and changing this part. Okay? The other part is just there. That's the definition of scientific notation. So, you have an example at the top of your page. What you do to change it, this is standard notation. Okay, this is how we would normally see numbers. And we want to write it in scientific notation. So we need a number 1 through 10. So I take the first digit and I put a decimal right in behind there. Because I only want one digit. So I got to put a decimal behind it. Okay? Then I rewrite that part of the number. Now I include everything after the decimal until I start getting a whole bunch of zeros. I don't need to write all those zeros down. Okay? Alright, my first number, my decimal, and then if any non-zero digit after that, I include it. Unless zero's in the middle. If I would have a zero in the middle, I would include it. Then I have this times 10, because remember that part's not going to change. Then to figure out what my exponent is going to be, I have to count my decimal all the way to the end. So I look at this as 1, 2, 3, 4, 5, 6, 7 spots. And then I'm done. This is scientific notation. That's it.
That's easy.
Okay? So you put a decimal in there, and then you count to figure out how many spots there are. Yes, ma'am?
Do you count the decimal?
You start at the decimal and count backwards. You count the spaces, not these parts, the spaces, so the loops. Okay? So let's look at number 1. Yes?
Do we have to write all the zeros down on our paper?
No. Okay? So, I'm putting this in scientific notation, so I need to put a decimal after the very first digit on my number. And then I'm going to rewrite that. I only need to write the 6 and the 1 because everything else behind it is zeros. Okay? Then I use multiplication. So then I say times 10, and then I count my spaces behind the decimal. 1, 2, 3, 4, 5, 6. And that's the number that goes up by the 10. And then I'm done. I don't have to do anything else. That's all I do. So basically you're just counting spaces. So, same with this one. I have to first put a decimal in between the two ones because I only need one digit in front of my decimal. Then I write that down. And I have times 10, and then I start at my decimal and count all the spaces behind it. And that is 4. So it's 10 to the 4th power. Okay, where would my decimal go in my last one? Chase. Yep, between what two numbers? 1 and 7. And then I include everything behind there until I hit all my zeros. Okay, and then I count. 1, 2, 3, 4, 5, 6, 7. Okay, now we need to go the other way. So now I start with this number. 3 and 5 tenths times 10 to the 7th. This one's not on there. Okay, so what I do is I rewrite my decimal. 3.5. And then I look at my exponent. This tells me how many spaces I need to move. So I need to move 7. So I go 1, 2, 3, 4, 5, 6, 7. And what do you think goes in these spaces? Zeros. And then I need to rewrite my number with all of my commas. Now, a nice way to double check to make sure that you have enough zeros or you don't have too many. So if I look at my exponent is 7, how many spaces do I have behind my decimal? Or how many numbers? 1. If I take 7 minus 1, that's how many zeros I should have. I don't put 7 zeros because I have to take and count that this is a space. So that's just a quick check. Let's try one on your paper. Alright, so you rewrite the decimal. So I have 3 and 2 tenths. I look at my exponent to figure out how many spaces I need to move, which is 7. So I make 7 loops. 1, 2, 3, 4, 5, 6, 7. And I add in my zeros in the loops. Oops. And I rewrite my numbers. Okay, I should see that I have a 7 here, but I have 1 space here. 7 minus 1 is 6. Do I have 6 zeros? Alright, should be good then. Make sure when you rewrite it that you get that decimal out of there. Should be at the very end right now. That's what we're doing with our exponent, is that's moving that decimal. Okay? Number 8. I rewrite my number. How many spots do I need to move? 6. So I have 1, 2, 3, 4, 5, 6. How many spots do I have behind my decimal? 3. If I take 6 minus 3, I get 3. Is that how many zeros you have at the end?
Yes.
Then that's what. So a quick check to double check that you're making sure you're doing it correctly. How many spaces do I have to move it?
4.
Okay, I have 2 spaces. 4 minus 2 is 2. That's how many zeros I should have at the end. Okay, so you need to finish the 6 problems that you have left on that sheet, plus those 2 from the other sheet, and then let me know, and that's how you're going to get your homework.